All right, so today's lesson is about multiplying and dividing monomials. Monomials was on your definitions at the beginning. It means something has only one term. So here we have one term times by another term. And as we get into algebra, now multiplication starts to be shown in a bunch of different ways. You've seen already, you don't always need the x for multiplication. In fact, we stop using it in algebra because we use x in other things as variables. So how do we show multiplication now? Sometimes brackets touching each other, as in all of these examples show multiplication. Sometimes they'll show it with a dot. 3 times 2. So you'll get multiplication in different ways. So this beginning part, okay? This is a warm-up. Here's the basic idea of multiplying two things together. You multiply the numbers together, and you multiply the variables together. And you're going to have to remember some of your powers and exponents unit from before. You're going to have to remember some integer stuff. For example, what's 5 times 4? 20. But then what's 5 times negative 4? Is it positive 20 or negative 20? Negative 20. Excellent. So we'd write this answer as negative 20. Question.
¿Cómo multiplicar pero que no se ve la X?
The x is now a variable. And we just, when brackets are touching, it's multiplication. Okay? All right. This one is actually really simple. All we're going to do is if you have x times 6, smush them together. You got, and we always write the coefficient first. So when we have a coefficient and 6 and x, that really means 6x. So if you were multiplying x times 6 together, this is how you would show it simplified. Here we have a negative x. Put on your math goggles, there would be a negative 1 out in front, and a negative 2. If you put those numbers together, what happens when you multiply negative 2 and negative 1? You get positive 2. So this one, you will have a positive 2 smushed together with that x, 2x. Smush these together. They're different variables, nothing you can do other than say x times y.
Pero le faltó la Z, ¿verdad? Abecedario, la X, la Y y después la Z.
Yeah. And then the third one. No, I said. The third one. Okay? The only number we have is a 2. If you put on your math goggles, there'd be a 1 here and a 1 here. And if you multiply 2 times 1 times 1, you would still get 2. We multiply all of our variables together. And you just have 2m and p. So multiplying monomials together gives us a monomial as the answer. Here, put your numbers together. What is 2 times 3 times 2? 12. Good job. And then put our variables together. We got x times y times z. Smush them together. X, y, z. Yes. If the variables are first in the number afterwards?
No, like if the order of the variables.
No. Generally, we like to put them alphabetically. So if you have more than one variable, A would come before B. X comes before Y.
X squared comes before X.
So
Sometimes it's like even by variable or
Yeah.
by exponent.
when you would have a polynomial and you're adding them.
Right.
But when we're writing a monomial like this, we like our variables in alphabetical order. Hey, math goggles, you see if you put them on, you'd have an exponent of 1. Exponent laws. If you have an x times an x squared, this is equal to x to the, yes, add the exponents, or just imagine how many you have, x times x times x.
This is going back to that power law stuff.
Alright, this one's smushed together, this is super easy, just be 3x. 8, put your math goggles on, there's a -1 there. What's 8 times -1? -8, and then you'd still have the x. Don't worry, they get harder. I know you're like, well, this isn't, don't worry, we'll get harder. But we have to know the easy stuff, straightforward stuff first.
No pause.
Numbers in front. Ooh, -2 and -5. If they're multiplied together, do you get positive or -10? Positive 10. Excellent. And x times x, you would get? No. Here.
One x.
No.
7.
One x squared.
X squared, right? There's our exponents.
When you say 2x,
That's different.
that's different.
X plus x is 2x. X times x is x squared. Math goggles on, a -1 times a +1 will give us a -1, and the AV can get smushed together. If you write a 1, it's not wrong.
Yeah.
But we don't have to write ones. You can just think of your math goggles.
But in health fitness, let it be known that you can have a negative add.
There we go. -4 times 3?
12.
No.
Negativo.
Yes. There we go. -12, and then we could have x. Why?
12xe.
Okay. It seems pretty straightforward, but we have to remember now we're adding, multiplying, and we've done adding already. So sometimes when they get combined with both of them, our brains can play tricks on us. Numbers multiplied together here, you're going to get -10. And how many y's are there?
4.
There's going to be 4, so we write that as an exponent of 4. And 4 times -10, -40. How many x's would there be? X to the power of 4. Excellent. So if we took what we just did here and wrote some rules, what have we noticed? We always multiply the numbers in front together. Here's some of your, a negative times a negative is positive, a positive times a negative is negative. So some things from our integers that we had before. So first, always multiply your coefficients. Second, if the variables are different, they just get smushed together. But if the variables are the same, then you have to use your exponent rules and say an x times an x becomes an x squared. An x times an x times an x becomes an x cubed. If the variables are the same, you have to do your exponent laws. Are the variables the same?
No.
Variables b and b.
Oh, wait.
They're not like terms,
No.
but now we're multiplying. Do we have numbers in front? Yes, they're ones, but 1 times 1 is going to be 1. You're going to get for this one b to the 5. This is just like our exponents unit. In fact, when I look for places to find you guys a homework sheet for this, I actually found better homework sheets in the exponents unit than I did in the polynomials unit. It's kind of interesting. So there's really a lot of review that we're doing here. Because we've done this already in our exponents unit, and it comes back in our polynomials unit. 5 times -4?
-20.
-20. Good job on your times table. How many x's would we have? 5 of them. How many y's do you have?
3.
3 of them. Excellent. Oh, we're doing really good on our notes so far. So this is multiplying. We also will do dividing. Dividing has the same idea as multiplying. Divide your coefficients. Divide your variables. So look at the coefficients here. 6 and 3. Can you do 6 divided by 3? What do you get? 2. Now we go to our variables. You have an x squared in the top and an x on the bottom. What is this? If you put your goggles on, that is an exponent of 1. Do we remember our exponent law for dividing? It'll just be x. X to the 1. Because the exponent law was I can subtract my exponents. The idea is the following. Like if I wrote out my x's like this, one of those x's cancels out with the other one. Because if you have the same number divided by the same number, 5 divided by 5, 1. 7 divided by 7, 7 divided by 7, 1. X divided by x, 1.
Happy face divided by happy face.
1. Can you do 8 divided by 4?
You need all this?
Yeah.
No, you can erase it.
Yes.
Yes, you can. You get 2. Do we have any variables the same? Yes.
2x.
Cancel those out, and we just get 2x in the end. Notes are not taking us very long at all, guys. You guys see how well you do on the homework.
Well, it's also a hockey game, right?
I know, and we'll have that on while you're working. Sound like a good plan?
Yep.
27 divided by 9.
3.
3. Can I simplify the x's? I'm gonna have just one x left, because I had 2 on the top, 1 on the bottom, 1 would cancel out, and we would just get an x. This is the simplified version. 'Cause there's nothing more we can do. Nothing left to divide. No like terms to put together. Negative 15mm divided by 3m. I'm going to just rewrite it because that dividing looks like this. I like writing things as fractions. Can you do negative 15 divided by 3?
5.
5. And would it be positive or negative?
Negative.
Negative. So we get negative 5. Those would simplify. And the only variable you're left with is n. Mr. Shirk is reviewing his exponent laws over there. He's giving some hints. So that's good. I'm going to end the video here for today.